Good day friends, welcome back. Now again we are here to discuss about physics. Now in our previous lectures we discussed about physical quantities, rest and motion. Now today we will expand a little bit more. Now let's talk about physical quantities. So we have 7 standard SI units, right? We have 7 SI units. How are those? Which are those? Like mass is a physical quantity. It is measured in kg, right? Then length, it is measured in meters, right? Then time, it is measured in second, right? Then temperature, it is measured in Kelvin, right? Then current, it is measured in ampere. Then substance amount, it is measured in mole, right? Then we have luminous intensity, it is measured in candela, that is CD. Now, apart from these 7 SI units, we have 2 other units, that is angle, it is measured in radian, and then solid angle is measured in steradian, right? So almost we have these 7 and then 2, total 9 units that we generally use. Out of those 9, these 7 are SI units and these 2 are complementary units, right? So almost everywhere in physics we are going to use these quantities with these units, right? Now let's talk about the dimension part also. Dimension, right? Now dimension is something which is denoted by a particular symbol. For example, mass is denoted in capital M form like this. Length, it is denoted, or basically the dimension will be like this. Time, of course, capital T. And temperature in Kelvin like this. Current, ampere, of course, like this. Mole, it is of course denoted in mole. Then luminous intensity, it is denoted in candela like this. And solid angle and this angle, they are dimensionless. They are dimensionless, both. angle and solid angle, they don't have any dimensions. So whenever it comes about to find out the dimension of angle and solid angle, we need to just mention it's dimensionless, right? Means it doesn't have any dimension, right? This point is clear? Okay. I hope you have noted down. Yeah, kindly note it down. Now, now we are going to discuss about what is the difference between speed, velocity, and then finally acceleration, right? Which are very important. Now, apart from all these things, before we start, in physics, we have various notations by which we denote any physical quantity. For example, let's suppose if velocity has to be measured, velocity, right? So generally we use small u or capital V or small v like this, right? On the other hand, when we have to represent the displacement, so we use this s. However, for distance, we simply use d or simple s, right? Acceleration, we denote with a, right? Force, generally, we denote it as f, right? Now, let's start with the speed. Now, what is speed? Now, the formula that we have been studying about speed is very simple. Lower standard, you must have studied. Speed is equal to distance upon time. Right? This is the formula that we have studied in lower standard. Right? Now, the definition of speed can be written or can be understood just by looking at the formula. Now, what it says that the ratio of distance and time is known as speed, right? So the definition that comes is distance covered by the body per unit time is known as speed. Is it not very simple? Yes, of course it is. Let's have one more time. Speed is defined as the distance covered by the body in per unit time. Correct? Is the point clear? Means it is nothing but distance covered by the body in per unit time. Yes or no? Now, what will be the unit of speed as distance upon time is there? Means it will be, what is the unit of distance? It is meter, right? So it will be meter divided by time means second. So the unit has become meter per second, right? I hope this point must be clear. displacement. Sorry, velocity. Now, velocity. Similarly, the velocity can be explained as, can be defined as displacement upon time. Right? Now, what will be the definition? Definition will be displacement covered by the body in per unit time is known as velocity. Right? Yes or no? Now, what is displacement? As here, now again let's come back to the figure. Here the body was initially at point A and finally it then in the next time interval, which is t is equal to t time, the body reached at point B and finally it reached at point C at time t is equal to t dash. Right? So the distance covered by the body is AB and BC. But what is the displacement? That is AC. Now, this AC is nothing but the displacement covered by the body during this complete journey, right? So what we can conclude is the displacement is nothing but the shortest distance covered by the body from initial point to final point. So that's why it is having magnitude. Magnitude is basically the length of this shortest path and the direction from initial to final, right? This point is clear. So here we are talking about this displacement, not this distance, correct? Now look at my finger, look at the pointer. We are talking about this distance, which is basically the displacement, not this, correct? So the velocity is basically the displacement covered by the body in per unit time, right? So we can write displacement covered by the body in per unit time, and of course it will be in meter per second, right? I hope the point must be clear. Now, the acceleration part. If you want to note it down, you can note it, right? It's very important. These definitions are basically the building blocks of physics. Motion, right? Now, the most important definition we are going to study, that is acceleration. It is denoted by small a, right? Now, what the definition is? The definition is basically rate of change of velocity per unit time. Now, what is this? Rate of change of velocity per unit time is defined as acceleration. Again, I repeat, acceleration is defined as rate of change of velocity per unit time. Now, what is the first you need to understand the keywords? Rate of change of velocity per unit time. Now, what is first change of velocity? Change of velocity means A must be equal to change in velocity means final velocity minus initial velocity. Yes or no? Now it says rate of change of velocity. Change of velocity has been considered per unit time, right? Means you need to again divide it with time. Correct? So finally you got A is equal to V minus U upon T, right? Whereas V is the final velocity right? And U is the initial velocity. Now is the point clear or not? Right? V is the final velocity and U is the initial velocity, right? Divided by total time taken by the body from initial to final, right? Is the point clear? Now here in this figure we can calculate the acceleration of this particular body in two time intervals, right? First one was from here to here and second one was from here to here, right? Or else from here to here, correct? This one is clear. So it's up to us what exactly we prefer. Now it may possible that these values may differ, or it may also be possible that the value of acceleration may be constant. So then we can say the body moves with a constant acceleration, right? I hope the point must be clear, right? So what we have studied? We have studied rest, we have studied motion, then we have studied about distance, then displacement, then speed, then velocity, and then finally acceleration. Now basically in this definition, why we call acceleration? Because the final velocity has been increased from the initial velocity, right? So that's why it is acceleration. Now imagine the second condition. Second condition must be that, let's suppose you are driving a car, right? Let's suppose with a velocity of 50 km per hour, right? Now after some time what happens? You apply a brake, right? Now once you have applied a brake, so what will happen? The velocity will start reducing, right? Now once the velocity starts reducing, so what is going to happen? You had a higher velocity, now from higher velocity you are getting reduced, right? So that will be called as retardation, right? So you have understood? We have acceleration and retardation, two different things, correct? So in acceleration, rate of increase of velocity per unit time, right? Whereas in retardation, rate of decrease in velocity per unit time. And of course, the unit, what has to be the unit? Now, let's talk about the numerator part. Numerator part, V and V, same quantities can be subtracted or added, right? Means, let's suppose if you have 5 apples and another person has 10 apples. So total how many apples? 10 plus 5. We can say yes, 15 apples. But let's suppose if you have 5 apples and other student or other friend has 10 bananas. So then total how many apples? Still 5. You can't add 5 plus 10, right? So remember this thing very well, that same quantities can only be added or subtracted, right? So in the numerator part, what we have seen, that its change in velocity means, of course, it will be in velocity, in terms of velocity, right? So the unit of velocity is, of course, meter per second, right? Now again divided by time, so it is second. So finally what you will get? It will be meter per second square. So in short we write meter per second square, or meter second raised to power minus 2, right? Now this is very important, because in physics most of the time we look at the unit also, right? And by unit we have a lot of ideas, correct? Hope you must have understood and you must have enjoyed physics, because this is the beauty of physics, that if you are able to observe the physical world in the way it is, I'm telling you, the magic will be created and physics will be the most interesting subject and the easiest one, right? I'm telling you, my friend, no any subject has that sort of beauty to beat physics, right? Why I'm saying? Of course, why experience. You can imagine the situation that there is somebody who is in Europe, let's suppose in Germany. If he has the correct understanding and you sitting in India have the correct understanding, your thoughts will be matched, right? This is the beauty of physics. Now in our next lecture we will discuss about force, right, and laws of motion and equation of motions, right? Till then, bye bye, take care.